You're witnessing what astronomers call a stellar nursery region, where young stars, only a few million years old, are being born. This breathtaking scene was captured by the James Webb Space Telescope, marking yet another breakthrough that has stirred excitement throughout the scientific world, in a development that challenges long-standing cosmological models. The James Webb Space Telescope, JWST, has reportedly detected an astonishing 750 galaxies, beyond what was previously believed to be the edge of the observable universe. This isn't just a remarkable demonstration of the telescope's powered forces, us to rethink the very structure of the cosmos itself. The concept of the observable universe is grounded in the idea that light has a finite speed, because the universe began approximately 13.8 billion years ago. The furthest light we should be able to observe, considering cosmic expansion, comes from around 46.5 billion light-years away in any direction. This creates a kind of cosmic bubble, with Earth at the center. Beyond this horizon, according to standard physics, galaxies should be unobservable, not because they don't exist, but because their light hasn't had enough time to reach us yet. Somehow, JWST has detected signals that appear to come from well beyond this boundary. These detections are not vague or speculative. They have been confirmed across multiple observations, rigorously analyzed, and filtered for potential errors or interference. If these findings hold up, they represent a stunning shift in our understanding of the cosmos. This leads to profound implications. Are our models of light propagation in an expanding universe flawed? Could there be some illusion or misinterpretation at play? Or more provocatively, has JWST truly seen past the theoretical edge of visibility? What makes this discovery even more compelling is the nature of these distant galaxies. Spectroscopic analysis suggests that they are not primitive or chaotic. On the contrary, many exhibit clear structures, spiral arms, dense star clusters, and signs of significant stellar activity. This indicates they are not just early-stage clouds of gas, but rather developed or developing galaxies that may have existed for billions of years. This raises a host of new questions. Were these galaxies formed in a separate region of the universe? Under different conditions, are we witnessing them due to some extreme curvature of space-time, perhaps magnified by gravitational lensing on a previously unimaginable scale? Or could this be evidence that our observable universe is only a small fragment of a much larger, more intricate cosmic structure? For decades, cosmologists operated under the assumption that although the universe might be infinite, we could only observe a finite part of it. Now, JWST may be showing that under certain conditions, this boundary is more flexible than previously thought. One possible explanation involves the early inflationary period of the universe, an incredibly rapid expansion that occurred just fractions of a second after the Big Bang. Some models of inflation suggest the universe may have split into bubbles or regions with different physical properties. Could JWST be detecting light from one of these alternate regions, somehow reaching us despite the theoretical constraints? There is also speculation about gravitational lensing. Foreground galaxies or massive clusters could be bending and magnifying light from more distant sources. But while this phenomenon can explain the magnification of isolated objects, it becomes less convincing when applied to 750 distinct galaxies distributed evenly across the sky. The number suggests something much more systemic. It's as if a curtain we never knew existed has been gently lifted, revealing an expanse of ancient galactic civilizations burning quietly in the cosmic dark. These galaxies may date back to moments astonishingly close to the universe's beginning. If JWST is detecting their light, then that light has traveled for longer than any previously observed, perhaps illuminating the earliest epochs of cosmic history. These galaxies could help us uncover the origins of stars, the formation of black holes, and even the first heavy elements produced after the Big Bang. Their presence could offer critical insights into dark matter and dark energy, the elusive components that are thought to make up about 95% of the universe's total mass and energy. If JWST is truly seeing into previously unreachable regions, we may discover unexpected distributions of matter or entirely new states of energy. Every galaxy adds a crucial data point to an already intricate cosmic puzzle. These findings extend that puzzle into a previously invisible dimension, forcing scientists to rethink the nature of time and causality itself. If we're seeing galaxies from beyond the edge of theoretical visibility, perhaps the flow of time is not as rigid or uniform as once thought. Concepts that once lived solely in philosophical debates, like time flowing differently across the universe, may now find grounding in real data. Technically, this accomplishment is staggering. JWST achieved it using deep field imaging at the same patch of space for days or even weeks, filtering out background radiation, cosmic dust, and interference from nearby stars required immense precision. The telescope kept it near absolute zero and stationed at the second Lagrange point, represents the pinnacle of engineering and scientific collaboration. This breakthrough opens up an exhilarating new chapter in astronomy. The universe, once seen as vast but bounded, now appears more limitless and layered than ever imagined. There's a poetic irony here. In our quest to find the edge of all things, we may have discovered that no such edge exists. These galaxies hint at a cosmos far more complex and connected than our boldest theories dared suggest. The psychological impact of this discovery is not to be overlooked. Every great astronomical leap from Copernicus moving Earth out of the center to Hubble, revealing other galaxies, has reshaped our understanding of humanity's place in the universe. Now, JWST is pulling back the veil once again, humbling us, yet elevating our sense of cosmic belonging. While JWST's mission continues, the detection of these 750 galaxies is a milestone. It forces a reconsideration of foundational physics. It urges us to redefine concepts like visibility, distance, and even existence in cosmological terms. Once again, humanity finds itself standing at the edge of the unknown, guided only by our curiosity and the instruments we've created to extend our vision. The implications extend into theoretical physics, sparking new debates in quantum mechanics, relativity, and the nature of cosmic inflation. Could these galaxies imply the universe is older than we believe, or more layered, with tunnels or folds in spacetime that allow light from other realms to slip through? Perhaps what we're seeing is evidence of unknown quantum gravitational phenomena. There's even the provocative possibility that these galaxies are part of another universe, one that coexists with ours in a multiverse. This concept, once dismissed as speculative, may now deserve serious exploration. If JWST has given us a window into another universe, it could catalyze a new era in both science and philosophy, beyond the scientific ramifications. This discovery deepens the philosophical implications of human existence. As our understanding of the universe expands, so too does the scope of our questions about consciousness, life, and our place in time and space. These galaxies don't just stretch the boundaries of the observable universe, they stretch the limits of our imagination. There is no final answer, here only a widening path of questions beckoning us forward. The galaxies are real, quietly shining in the cold dark, waiting for us to see them. And now that we have, our view of the cosmos will never be the same. The confirmation of these galaxies, using the most advanced instruments and verification methods, has placed scientists at the brink of a cosmological paradigm shift. The flood of new data is already challenging established models in fundamental physics. One especially significant impact is on our understanding of cosmic inflation. This event, believed to have shaped the universe's structure just after the Big Bang, may have been far more complex than originally thought. If the early universe varied in density or symmetry across regions, it could explain why these galaxies appear in what was thought to be empty space. It also raises the need to revisit our assumptions about the shape of the universe. General relativity teaches that mass bends space-time, and on a large scale. This determines whether the universe is flat, open, or closed. The presence of galaxies beyond our theoretical boundaries suggests that space-time could be curved in ways we haven't yet detected. Perhaps light has taken longer, curved paths through a warped cosmos, making distant galaxies visible when they should not be. non-Euclidean.
I'll bet you were.
Space bends and warp scoot become central to future models. Light might be slipping between the cracks of higher dimensions or bending around exotic gravitational fields. It's effectively turning JWST into not just a time machine, but a multi-dimensional observatory. These observations could also shed light on one of cosmology's most puzzling components, primordial black holes. Some of these newly detected galaxies appear to contain massive black holes, despite being from a time when such structures should have barely begun to form. This suggests that black holes may have emerged far earlier and more commonly than previously believed, perhaps even from quantum fluctuations in the early universe. Spectroscopic readings of the galaxies. Light may also reveal the presence of heavy elements like carbon, oxygen, and nitrogen.